Another incident on the subway today raises questions about passenger safety.
New York City. Millions pass through its streets and its vast underground every day. But as commuters wait for trains, they're not alone. Hidden between the tracks and tunnels, a creature has been quietly evolving for decades, perfectly suited for this man-made world. Today, we're going underground to uncover the secret of one of NYC's most fascinating and unsettling creatures, the subway mosquito. A species that didn't just survive, but thrived where no other mosquito could. This is a story of hyper-evolution, shocking adaptability, and a wake-up call that our cities are literally creating new life forms right under our feet.
In 1998, entomologist Dr. Richard Desmond descended into the 14th Street station with an unusual mission to hunt mosquitoes. Commuters had reported being bitten, even in winter. What he discovered would rewrite the rules of urban evolution. It was like discovering a new species on a remote island, except this island was man-made, beneath one of the busiest cities in the world. The insect was Culex pipiens molestus, a mosquito that had genetically diverged from its above-ground cousins, evolving traits to survive exclusively in the subway's environment. And the most shocking part? This evolution happened in barely a century, a blink of an eye in evolutionary terms. Its name says it all, molestus, Latin for annoying, a nod to its relentless bites.
What makes the subway mosquito so remarkable are its extraordinary adaptations, its survival toolkit for life underground. Adaptation number 1, autogeny. Unlike normal mosquitoes, females can lay their first batch of eggs without feeding on blood. Later, when they do seek blood, they prefer rats over humans, an obvious advantage in New York's rodent-filled tunnels. Adaptation number 2, no hibernation. While surface mosquitoes die back in winter, subway temperatures stay constant. These insects remain active year-round, reproducing non-stop and multiplying far faster. Adaptation number 3, low light vision. Their compound eyes evolved more light-sensitive receptors tuned to artificial light. They navigate dark tunnels with ease and are even drawn to fluorescent station lamps. Adaptation number 4, pollution resistance. Subway air is filled with brake dust, metal particles, and toxins. Yet these mosquitoes breathe it in with modified spiracles that filter pollutants and an immune system armed with over 100 detox genes never seen in their ancestors.
The subway mosquito's life cycle is perfectly tuned to its habitat. It begins in small puddles formed by leaks and condensation in the tunnels. Females deposit eggs that hatch quickly in the stable underground climate. The larvae feed on bacteria thriving in polluted water. Bacteria that live on motor oil, fuel residue, even heavy metals. In just 7 days, twice as fast as their surface cousins, they mature into adults ready to restart the cycle. Mapping studies show their swarms concentrate near busy transfer hubs, exactly where human traffic is highest. Coincidence? Scientists don't think so. Though they prefer rat blood, these mosquitoes will bite humans when given the chance. Reports of winter subway bites have surged over the years. But the real danger isn't the itch, it's disease. In 2019, Columbia University researchers confirmed that subway mosquitoes can carry multiple pathogens, including West Nile virus strains. Health officials warn an active mosquito population thriving all year long in constant contact with infected rats poses a unique public health risk. The MTA has spent millions on monitoring and control, but traditional mosquito eradication is nearly impossible in a 24/7 transit system, moving millions of passengers daily. Beyond the immediate concerns, this mosquito is a case study in fast-forward evolution. Geneticists are sequencing its DNA to understand how species adapt so rapidly to artificial environments. And New York isn't alone. Similar underground mosquito populations have been discovered in London, Moscow, and Tokyo. We are witnessing evolution in real time. These mosquitoes prove that cities aren't just human habitats, they're evolutionary laboratories, spawning new forms of life. The subway mosquito's story is one of resilience and adaptation, a reminder that no matter how advanced our technology becomes, nature always finds a way. Next time you step down into the subway, remember, you're not just entering a transit system, you're stepping into a living ecosystem, home to one of evolution's most astonishing experiments happening right beneath your feet. If you enjoyed this story, give the video a thumbs up, subscribe for more, and hit the bell so you won't miss our next deep dive into the hidden world of urban insects. See you next time.